Chapter 7, Atmospheric Pressure and Wind. 7.6, Actual Global Surface Circulation. So let's look at actual global surface circulation. Now, circulation on the surface of the Earth is quite variable from day to day, month to month. So our best approach here is to use an average of a certain number of years of record. And I'm lucky to have 50 years of record, and we can use these 50 years to see what are the average circulation patterns that exist for the surface of the Earth. And you're going to see that these patterns only differ a bit from the three circulation model that was shown in the previous section. And the area where we have the biggest differences is the northern hemisphere, not the southern hemisphere. These differences are caused primarily by the fact that the Earth's surface is not composed of uniform materials, but two surface types, land and water. And this is a bigger problem in the northern hemisphere than in the southern hemisphere. So the surface materials of land and water behave quite differently in terms of heating and cooling. And this causes latitudinal pressure zones that we expect to see at 60 degrees north to be less uniform. The second factor influencing actual circulation patterns is elevation. So we have some areas of high elevation that disrupt the pattern. And these higher areas of elevation can cause pressure systems to be intensified, especially in winter. And I'm talking about the Himalayas. So this is true of high pressure systems in winter. In winter months, the Himalayas are going to produce a high pressure system that's more intense than it should be. So we're going to look at these maps. We're going to do a 50-year average of January patterns, and we're going to look at a 50-year average of July patterns. So here we have the 50 years of January surface patterns. So let's begin with the tropics. So that orange line is a zone of low pressure. That's the equatorial lows or the intertropical convergence zone. So I've put major L's where it's the strongest. And notice the winds at the equator should be blowing towards the equator, and they should be from the east in the northern hemisphere and from the east in the southern hemisphere. And these are the northeast trade winds and the southeast trade winds. And for the most part, especially over the ocean, that pattern holds true. So if you look above the intertropical convergence zone in the Pacific Ocean, those winds are coming from the east and higher latitudes. That's what you would expect with the northeast trades. Same pattern is seen in the Pacific. The pattern is upset a bit for the Indian Ocean in the northern hemisphere. For the southern hemisphere, the southeast trade winds seem to hold true for the Pacific Ocean, the Atlantic Ocean, and the Indian Ocean. The winds are moving from higher latitude from in an easterly direction, as we would expect. Along 30 degrees south and roughly 30 degrees north, we should have belts of high pressure, the subtropical high pressure zones. They do form nicely in the southern hemisphere, except for a low occurring over the lower part of South America and South Africa and Australia. Now we would expect, this is January, it's the summer months, so land is going to heat up faster than water and should form low pressure systems over continental masses. In the northern hemisphere, these highs move across from the Pacific Ocean over North America, over the Atlantic Ocean at 30 degrees. Then they move a little bit north of 30 degrees across Europe and Asia, and then down you can see it's not labeled, but in between those two fast green zones of wind in the Pacific Ocean, that would be a high pressure zone. The low pressure zone, the subpolar lows, forms a nice belt in the southern hemisphere, and we can see some highs coming from Antarctica further to the south, more poleward of those lows. In the northern hemisphere, they're disrupted by land masses. So the lows do form over the Pacific Ocean, it's called the Aleutian Low, and a low does form the Iceland Low does form beneath Greenland. But over land in the winter, this is January, over North America and Eurasia, is going to form a high pressure system. So the lows don't develop. The highs that you see above 60 degrees north in the northern hemisphere, those would be part of the Arctic high system. It's expanded, and we can see high pressure systems above Alaska, above it looks like eastern Siberia, and over Greenland. The winds, notice the westerlies do seem to exist in between 30 and 60 degrees, blowing from the west to the east, poleward in both zones. It's hard to make out the polar easterlies, but in some areas you can see that they are blowing as we would expect. Let's now look at July. First thing that's obvious is the intertropical convergence zone moves above the equator. It's still dominated by low pressure systems, but it seems to move more poleward over Asia and the Middle East, and then back down into the Pacific. The winds blowing either side of it do seem to be similar to the northeast and southeast trades, what we would expect. Now, if we look above those lows in the northern hemisphere, we can see that the subtropical high pressure zones in the northern hemisphere have dissipated for the most part. They do still show up in the Pacific and the Atlantic Ocean, but they're gone from Eurasia and replaced with low pressure. So a low pressure belt does exist in the northern hemisphere that makes up the subpolar lows just above 60 degrees north and moving across with longitude. In the southern hemisphere, the high pressure zone, the subtropical high pressure zone, forms a nice belt all the way across, and the winds generated from it above those highs. We have the southeast trade winds, and below those we have the westerlies. The low pressure belt in the southern hemisphere, the subpolar lows move a little bit more poleward, right up against the edge of Antarctica, and they generate mid-latitude cyclones just like the ones in the northern hemisphere do, and they meet up. On one side they have the westerlies, and the other side they have the polar easterlies, and we can see a bit of high pressure system associated with Antarctica. We can't really see any high pressure system associated with the North Pole. There would be a high somewhere above there. So the next image is an animation showing winds at the 800 millibar level between May 1st and July 25th, 2017. And I put it in here just to show you how dynamic Earth's wind systems is they're always changing. Um, but what we do see is dominant lows at subpolar zones about 60 degrees north and south. We see a low pressure system generating the northeast and southeast trade winds, and also the high pressure systems at the subtropics associated with that. I'm going to just run this, and it's kind of neat. It shows the bands of air moving, and so you can see in the northern hemisphere the winds do seem to be mainly coming from the east, the polar easterlies, and then below those polar easterlies we can see the westerlies, but embedded in those westerlies are these swirls. Those are the mid-latitude cyclones being generated by the low pressure systems that tend to park themselves in the Aleutian Islands and below Greenland. The flow near the equator is pretty much what we would expect in terms of the southeast and northeast trade winds. They're moving from the east to the west towards the thermal equator. In the southern hemisphere, those swirling masses that are moving across, so those are the subpolar lows along that subpolar low zone. And you can see the winds north of those swirling masses are indeed westerly in direction, coming from the west. Anyways, it's kind of neat. Here's another animation. You can see the surface winds over the North Atlantic in 2018. And once again, what I think is neat here, I know it's moving quickly, but you can see the number of mid-latitude cyclones being spawned off of the area around Greenland and moving into Europe. Anyways, the swirling masses that move. Oh, sorry, we're in winter, so a lot of these are actually swirling out of central North America and moving across, hitting Europe. And you can see the counterclockwise flow. You can also see that they have fronts associated with them. So they tend to have a line associated with the swirling mass. On one side of that line would be cold air to the left, and on the right it would be warm air, subtropical air meeting. And you can also see the oh, there's a doozy of a storm. The winds below, you can see down at about 30 degrees. It looks like there's a high pressure system. The winds being generated are coming from the west, moving to the east. So those are the trade winds in the northern hemisphere, and you can see the trade winds also in the southern hemisphere. Anyways, enough of that. It's mesmerizing. Oh, that's a hurricane there in the Atlantic Ocean, and that's October. Makes sense. It's still hurricane season. But what's really interesting is about how dynamic and swirling the Earth's atmosphere at the Earth's surface truly is.